Okay, sounds good. We got Logan watching.
All right, everybody. So here, we are doing this for our very first time. If you don't know me or you haven't seen me on TV, I am the Chief Meteorologist here at WACH 57. My name is Josh Knight. And on the other side of the camera, of course, at a safe distance, is meteorologist Samantha McCollum. And she's going to be following along and watching the Facebook Live to see your comments, see if you guys have any questions. And hey, there will be some question and answer back and forth, so hopefully she'll be able to let me know if anybody's getting those answers right. So today, oh, it looks like it started over for us. We are starting right now, and for our very first Facebook Live weather school here at the station, I wanted to focus on clouds. It's something that we see just about every day. We've got all sorts of different types. We've got different ways that the clouds are made, and ultimately it leads to a big part of our weather story every day. Now, if you live in South Carolina, if you are around here, us in Columbia, we've got sunshine pretty much wall to wall today, just a few nice puffy clouds out there. So what I want to start with is the different cloud types. Now, for some of my younger students that have been to their second grade classes or fourth grade classes, I know you guys know a lot of this stuff. So what I'd like to do is have you answer for me on some of these questions. Starting off with probably one of the nicest clouds, the nicest weather at least, these big puffy clouds out there. Now again, if you're watching at home and you know the answer ahead of time, please send a comment in and Samantha will give you some credit. She'll let us know who is responding to what. So we've got this one for you. I'll give this one to you. It looks like a big cotton ball out in the sky. And this, of course, is a cumulus cloud. Typically, we see these on nice weather days. How's our framing? Will it look okay? Mm-hmm. Cool. So we've got these clouds out there today, actually across South Carolina. A lot of times you start off with clear blue skies early in the day. Then these clouds start to pop up as we work our way. Just kind of look like puffy cotton balls. Again, really just a sign of good weather for us generally across the area. As we work our way here, you're flat on the bottom, and then they kind of billow up a little bit more as you get higher into the sky. And typically, again, for us, they are something that we look forward to. It just means that you got a nice, pretty day. These might be a little harder to see. If you're not familiar, this is the State House here in Columbia in South Carolina. But what we end up here with is just kind of this milky looking sky. Those are going to be our cirrus clouds. So those are generally really high up in the sky. Most clouds, the way they're named, is based on how high they are in the sky. Your cumulus are generally pretty low. Cirrus are much higher and are actually made of little tiny pieces of ice. So instead of water droplets, usually made of ice. They're thin, they're wispy, and they can kind of help us to see where the weather is coming from. They give us a good idea of what direction the wind is moving higher up in the sky. So kind of a weather, it kind of tells us, or rather helps us do the forecast just by looking up at the clouds in the sky. This one here is a not so pretty day. Now if you've studied this one in school, you probably can recognize that one pretty easily. This is going to be our stratus cloud. It's going to generally cover up most of the sky, gray and flat, and just kind of looks like a blanket covering up the whole sky. Then if they start to rain or if they start to snow during the wintertime, call it a nimbostratus cloud. Just nimbo there means that it is going to produce precipitation. So we end up with a little bit of rain, maybe some snow, and that one is a nimbostratus. This last one is one that we're probably all familiar with during the summertime. These are our cumulonimbus clouds. Sorry, I didn't give you a chance to guess on that one. Those are really tall, high up in the sky. Let me back up here for you, and you can see here, just to get a better sense for the size of this cloud. This is taken from really far away. So you know when you see those thunderstorms approaching during the summer, you get those really dark clouds on the way. That's what would happen as this storm gets closer. You can always tell that's a cumulonimbus cloud because they're really, really tall. And that's exactly what's happening here. So we've got our cumulonimbus cloud, and that's just another name for a thunderstorm cloud. If you're underneath of it, it's probably pouring, raining really heavily, and the cloud looks really dark. And the reason it looks so dark is because the sun is trying to go through so much cloud cover to get down to you, and that's why the skies get really dark as that happens. So dark from underneath, you can see really lit up from outside of it, but then very tall and often growing up taller. When they're growing up, we call that an updraft, and that's all this warm, moist air working its way into the cloud, and then essentially we end up with our thunderstorms. Again, if you're underneath of it, if you're not, and just kind of look pretty cool off in the distance. And because they're so tall, we can see them from really far away. A lot of times during the summertime, you might hear of this term heat lightning. All that really is a thunderstorm that's way off in the distance. It's still a storm, it's still dangerous for somebody, it's just so far away you can't hear the thunder, but you can see the lightning. So to talk about clouds, one of the things we've got to focus on is the water cycle. So we're talking about those three main words that end with shun. So if you, again, studied this in school, I'm sure this looks really familiar to you. We've got all this water here, the lakes, the oceans, the streams, the rivers, and it's sitting in there as a liquid, right? Our water liquid that you go swim in playing at the beach. But a lot of that is actually working its way back up into the sky. It's evaporating. So what happens is that water changes from a liquid to a gas. Now as that changes into a gas, we can't see it. It's invisible. It's not steam. It's really cold out and you breathe and you can see your breath. That's not what we're talking about. We're talking about water vapor that's entirely invisible. Then once it gets up here, it turns into actual little tiny cloud droplets. That one is condensation. And the last one, anybody remember that one? Starts with a P. That one, of course, is precipitation. And that's what's happening over here. Could be rain, could be snow, could be hail, sleet, all sorts of different kinds. So now this is really where we kind of get into the crux of what we're talking about here. We've got our cloud, but let's dive in and take a closer look at what's going on in there. We had evaporation, so we had all of these water molecules floating around that we couldn't see as a gas. But then they start to appear again as little tiny cloud droplets. To give you an idea how small those are floating around in the cloud, oh, I forgot my ruler, yes, Sam, if you can grab it. They're about 0.02 millimeters. So we are talking really, really tiny. So I've got this here for you, and if we could take just the smallest spot on your ruler, and then we broke it down into 1,000 different slices, and then only took 2 of those little tiny slices, that would be about the size of a cloud droplet. So really, really small. So compared to an actual raindrop, to give you an idea on the size, these cloud droplets floating around in the cloud, they're that small, and if we had it to scale, the raindrop would be that big. It's about 100 times bigger. So that gives you kind of an idea of why those clouds are able to float up in the sky. Gravity wants to pull them down, but they're just so small, they're so light, they're able to just kind of continue floating around up there. So it takes about 100 of those to come together to make one raindrop. And once we get so much water up there in the cloud, eventually it does start to rain. So now I want to get to some of the fun stuff here. We are going to do a couple things to make our own clouds. Oh,
one question.
Yes.
We have a question from Tina's niece Janaya. She wants to know which cloud makes snow.
So which cloud makes snow? That is going to be the same with our nimbostratus. And sometimes they can come actually from thunderstorm clouds during the winter. And that's where we end up with thunder snow. So really just a cloud that has so much water and ice in it, it gets so heavy that it falls out. So here's the kind of the real main point to when we talk about forecasting cloud cover. We get these cloud droplets that form from water vapor rising up into the atmosphere. Now, 2 really important things happen when the water vapor rises. As it goes up higher and higher in the sky, the temperature gets colder. So we go from down here on the ground where it's pretty comfortable, it's pretty warm, up higher in the sky, it's a lot colder. Sometimes and pretty quickly it can get below freezing. So it's getting colder as we go higher into the sky, but the other thing that happens is the air pressure gets lighter, less and less air pressure up there, and that is going to be one of the big reasons that we get our cloud cover to develop. So if you think about air pressure, it's kind of weird, but right now, sitting on top of my head, your head, pushing on your stomach in every direction is air pressure. It's about 15 pounds of it. You don't feel it. It doesn't feel like you have 15 pounds sitting on your head because it's there every day. But what happens is we go higher and higher in the sky, there's less and less air sitting on top of us, so that air pressure gets lighter. You can think of it kind of too the way if you're in the swimming pool. You know, if you swim in the pool, you go down into the deep end, you can feel it, right? Feel it on your ears, feel it on your face even. That's all that water pressure sitting on top of you, kind of squishing you. The same thing is happening with the air. It's a lot lighter, but it's always sitting on us and it's pushing on us. But as you go higher and higher into the sky, that drops. It'll happen too if you maybe are driving through the mountains. You know, if you go up a really big hill, sometimes your ears will pop. That's the same thing, it's that lower air pressure. So that is the biggest thing for us to get clouds. have to have water vapor rising in the sky, it gets colder, and then the pressure drops. So we have all sorts of different reasons that might happen, but I want to make a few clouds for you first. Yes, Sam, question?
We have another question from Emma, Katie's daughter. She wants to know why the clouds get gray before it rains.
Ooh, that's a great question. So a lot of times the color of the cloud is really just going to be dependent on how thick it is, and often how much water is up there, how many tiny water droplets and how many rain droplets are trying to get together to come out of that cloud. So a lot of times it'll get really gray and really dark just because the sun can't get down through the clouds. We're going to be talking about that sunshine here. And so what I want to do is kind of recap a little bit and make a cloud. We talked about two ways that they're made. One is the pressure dropping as the water vapor goes higher and higher in the sky. And the other is the temperature getting colder. So we're going to do both ways. First, we're going to start off here with the pressure dropping. I've got this 2-liter bottle. In here we have some water. So we've got our liquid water, let's say like what's out in the lake, in the ocean. Then all throughout here, we can't see it, but floating around is the water vapor. It's that gas. It's invisible water. All these little teeny tiny molecules flying around in here. What I want to do is kind of fake what happens up in the atmosphere. So I've got this air pump here. Sam, how's this framing look? We're going to be okay? Looks
Yeah,
good?
you look fine.
So we've got normal air pressure in here, about 15 pounds of air, kind of pushing down on everything. But what we're going to do is pump it up. We're going to make that air pressure go a lot higher. You're not going to see too much happen at first. So let's see here. If you guys are at home with me, if you can count along, we're going to do 10 pumps of air. So you can see now I can squeeze the bottle. It's not really that tight, not that much pressure. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let me keep this on here nice and tight, and I'm going to flick this, and you can hear just how, oops, we got some things in the way. You can hear how much air pressure is in there. So what happens is it's really high pressure, and I'm going to pop this top off, and all at once, it's going to go from high to low. So just like in the sky, when that water vapor goes up, the air pressure slowly gets lower. This is going to go high to low really quickly. You ready? Let's go 1, 2, 3. So, I don't know if you guys can see easily at home. I'll get pretty close. Sam, let me know how that
Yeah, you
looks.
can see it.
So you can see, and if you look closely out the top, we're able to get that cloud to come right out of the bottle too.
Wow.
So what's neat is all of that water vapor was floating around in here. We just couldn't see it. We had to get it to condense out. So it had already evaporated, but we were trying to work on that second part of the water cycle. We wanted to get the condensation. So that's what we do. Now this is probably what I think is one of the coolest parts. So we've got our water vapor, or rather our water droplets floating around. We've got our cloud. What do you think will happen if I put air back in it? If I go back up to high pressure? I'm trying to do it so you can see it pretty well. So we've got our cloud in there, but watch this. Can you see it? It completely disappears. So the same sort of thing would happen in the sky. If we had a cloud that was floating around up high in the sky and all that air just started to come down, the cloud would disappear too, because the air pressure would go back up and the temperature would start to warm up. So let's do this one more time. Let's make this cloud. Let's go 1, 2, 3. Hold on with 2 hands here. 4, 5, 6, 7, 8. All right, you ready? And again, this is for air pressure making our cloud. 1, 2, 3. Let's see if this time maybe we can pour a little bit out for you.
Wow.
So pretty cool, right? Now, of course, this is not exactly how the clouds are made in the sky. We don't have air pumps and 2-liter bottles, but it's the same idea. We've got air pressure down here. It gets lower and lower and lower as we go higher up into the sky, and that's why those clouds start to develop. The water vapor, that invisible water gas, turns into little teeny tiny water droplets. So now I told you we're going to do it both ways. We've got the air pressure portion here, but the other way that we get clouds, Sam, can you do me one more favor? I think in that bag on the chair, I have a little book of matches. So there's one other thing that is often used to make clouds that I did not talk about, and that's a fancy thing we call condensation nuclei. All that means is that there are little tiny things floating around the sky like pollution, pollen, dust, sometimes sand from deserts, and all of that is actually something that clouds use to cling onto. Those little water droplets want something to hold on to form. So what we're going to do is start off here. No air pressure this time. This one will be all temperature based. I've got water in this jar, so the same deal. Inside here we've got water vapor floating around too. You can't see it. There's a little bit of water here on the actual glass, but what we're going to do to get ourselves some condensation nuclei is take a match. And what will happen, that match will go, let's see if I can get it to go, maybe a different match. That will create some smoke for us, and that smoke is a perfect example of condensation nuclei. So if you try this one at home, make sure your parents, of course, are lighting the match. But we just drop that right in there. So now there's some smoke in here too, and that smoke will act as basically to kind of seed our clouds, to get them started. So what I'm gonna do is put this on here. We've got some smoke in there, our condensation nuclei. We have our water vapor floating around that we can't see. Now this one, Sam, I might need you to move the camera for a little bit because this one's a little bit tougher.
Closer.
What I'm gonna do, I'm gonna sit it up here. So you might just wanna, I don't know if you have to pick it up completely. I've got my water in there, we've got our condensation nuclei, and all I'm gonna do is put some ice on top of this. Now this will be one that we'll come back and see again. So we've got now that water vapor, instead of changing the air pressure, we are changing the temperature. So if you look closely here, you might have to get really close, Sam. I don't know if it'll zoom in very easily for you. But actually, no, here, let me come to you.
Okay.
So if you look really close, you let me know how that is framed up. You might already be able to see a little bit of a cloud forming inside that jar. So what's happening this time is all that water vapor was floating around, but instead of changing the air pressure, we're changing the temperature. It's cold at the top of that jar because I put ice on top of it. So you can see that cloud starting to condense in there from water vapor back into actual little teeny tiny cloud droplets. So what I'm gonna do is actually sit this over to the side, and we'll come back and look at it in a few minutes, and you'll be able to see that there's a lot more of a cloud that's able to form in there.
I think up against the black, you'd be able to see it really
perfect.
good too.
So I'm gonna leave that right there.
See it getting smoky looking?
And so it looks like smoke. It looks like, hey, that match must have really put a lot of smoke in there. But what it is that's all those the water vapor, all the gas turning actually back into liquid. If you try this one at home, it's really easy to do, and it's kind of neat. As soon as you put those ice cubes on there, you can actually see that cloud kind of starting to appear inside the bottle. Again, we'll come back, we'll take a look at it once that air in there has cooled down even more, and you'll be able to see that there's even more of a cloud in there. So the last thing here is why in the atmosphere do we end up with that rising air? Why is the water vapor going up in the first place to make clouds? And that for us as meteorologists is one of the biggest reasons why we are trying to forecast the cloudy days, is to figure out what's forcing the air to go up in the first place. One of the most common things is exactly what happened around Columbia yesterday. As the sun came out, it was perfectly clear, blue skies in the morning. Question?
Well, someone asked how it would work with hot water, so it is warm.
So the water, that's a great question. So the water that I put in that jar is warm. Basically, that will put more water molecules into the air as a gas. If your water is colder, it's just not going to release as many water molecules into the air as a gas. So that hot water will allow it to work better. You can almost think of it as the same way as when you take a hot shower and you end up with so much steam in the air. It's because that hot water has an easier time kind of escaping and floating around. So that's a great question. But yeah, that'll just make it look even better when you're doing it. So we've got the sunshine, came out yesterday, perfectly blue, clear skies. We get all that sunshine to heat up the ground, and what starts to happen is just like a hot air balloon. We've got our hot air balloon, you fill it up with air, and then you turn on that flame, it gets really hot, and hot air rises. So yesterday, that's what happened. Sun came out, heated up the ground, all the air down here starts to float up. Now we can't see it at first, I just kind of made it look like that so it's easier to understand, but as it continues to float up, 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 it's warmer than all the air around it, then it gets up there, and eventually it will turn into a cloud as well, as it gets high enough in the sky and as we get those colder temperatures and the lower air pressure. Then, lastly here, probably one of the more common ways that we see and can make it a little bit more challenging to forecast is frontal boundaries. When we end up with warm air and cold air moving and taking over from what's already there. So here's a great example. As warm fronts move through, as warm air pushes in, what it does is ride up and over the cold air that's stuck in place. And that's why when a warm front comes through, sometimes we end up with just kind of a cloudy, dreary day because we get all that rising motion from that warm front pushing across the area. And on the flip side, the other one that we can end up with is going to be a cold front. And what that cold front will do is the cold air comes in, and instead of going up and over the warm air that's already there, it's actually going to dig down under the warm air, and that lifts the warm air up. So it's kind of a little bit of a complicated thing, but the cold front is a symbol for us that colder air is moving in from one direction. So as that cold air slides in, it basically is kind of like a shovel. It goes under the warm air, lifts it, pops it up into the air, and as that warm air rises, that same thing happens. We end up with cooling, and we end up with lower air pressure, and those clouds do start to develop. So those are kind of the big things for us. Again, let me see here, Sam. Let's see if we can... It looks like our cloud, some of it looks a little bit better. We've lost a little bit. I'll pop off the top here and you might get a better sense. But there's a little bit of a cloud in there. How's our view? We okay?
Yep, looks
good. What I'm
good.
going to do is take this off. Try not to get too much ice water melting on our desk here. But I'm going to take this off and hopefully you'll be able to see some of that cloud actually come out of the jar. It's tough to see. I know maybe on the black you get a better sense here. You see it floating out just a little bit. Maybe if I
turn the
kind
light
of
up
blow
a little
across it. Yeah, so Sam's got the light on for you. So if we, let me see if I move it out of that. There's a spotlight there from one of the lights in the ceiling. But this is a really easy one to do at home. It's pretty wild to watch. As soon as you put those ice cubes on there, you can see that cloud just forming right at the top of the jar and then sinking down into the bottom. You can use anything. You can use a flower vase. This is just a little ball jar, but as long as you've got
some questions
some
about
ice
what
cubes.
size. Any size requirements for that?
No, not really. I think the bigger you have, probably the more impressive. I just choose for your glass jar, or hey, it could be a plastic bottle too. Just something that you can see through easily. The easier you can see through it, the better. I'd recommend, it doesn't have to be hot water, but definitely at least warm water. And then just light your match and then drop it in. You might get a cloud if you don't do the match step. You can certainly try it, see what happens both ways. But the match, that little bit of smoke, just kind of helps all those water droplets adhere to something, and that's why we end up with such a good cloud.
And then the pressure cloud, does that bottle have to be a 2 liter, or can that be?
That does not have to be a 2 liter. Let me see, where did I even put it? Yep, so that's just, for me, that was an easy way. You really do have to be able to get a decent amount of air pressure in there for it to work. So for me, what I've done is
That's like a bicycle pump,
yep,
right?
it's just a bike pump, and I have a little rubber stopper that fits the 2 liter bottle. So this one is definitely easier to do and probably stuff you already have at home. You could do pretty simply. This one I had to buy a couple things for, but the biggest trick is just being able to hold that air pressure in there until you're ready to really pop it off. I'll do that one more time because that one's pretty impressive. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would not over pump it by any means. You don't need to go crazy here, but if we go 1, 2,
wow.
so that one always makes a better looking cloud. And you see here, I don't know if I'm too close, Sam, but
Nope, looks good. Perfect.
You get the idea. This one's neat too because it kind of makes that loud noise. But honestly, I think so. We've got our cloud in there, and this is really, as far as the learning part, this is a really helpful kind of reminder that high pressure, you can just see that cloud just completely disappears. So this is one of my favorite little experiments to do because it really helps tell the story. Low pressure days, typically not very nice weather. High pressure days like this, we generally see more sunshine. That's exactly what's happening in Columbia today, really a lot of the East Coast. But then we pop this off, we'll go low pressure, and you can see it's that same sort of thing. So this is one of the ones I like to do at school visits as well. So if you've seen me at your school, this looks a little familiar. But this one, again, really easy to do at home. And as soon as you put those ice cubes on, you get a pretty good idea of that cloud starting to come together. So at this point, guys, please ask any questions you have. Samantha's kind of keeping an eye on the comments. Give you a little bit of a preview for next week here. We're going to start doing these. Today was going to be on Thursday, but after today, we're going to do them Wednesdays at 1 o'clock. And we're going to cover all sorts of different topics. If you have a topic you'd like us to talk about, just let me know. But next Wednesday, I think we're going to focus on air pressure. We talked about it a lot today with our clouds, high pressure, low pressure, how much is out there. But there's also some pretty cool experiments we can do with air pressure. So I think that'll be a fun one for us. And we can talk about a little bit more on how it relates to the different types of weather out there. The simplest way is that high pressure is generally nicer, sunnier weather. and low pressure is generally stormier weather, but there's a lot more to it, so we'll dive into that a little bit more. If you have any questions, please shout them out now, or of course comment there. If not, I'll run back through and look at the comments a little bit later and hope to answer some more of them for you. But again, really thank you guys for tuning in. Hopefully you learned something, hopefully you enjoyed it, and pretty easy experiments to do with the kids while they're at home away from school, and just some fun way to kind of keep on learning. Sam, are we good?
We're all good. We got some adults that are enjoying it, saying that they're loving it more than the kids. And
I might have gone a little too deep on some spots. So feel free to share those comments too. If it's over everybody's head, that's be sure to let me know.
Yeah, and if your kids are busy right now, they can always watch this later.
Yeah, exactly.
Too.
So this will live, of course, like Facebook Live videos do, on our Watch Fox account. So hopefully you can head over there.
We do have a question from
Yeah.
Logan. Logan says, "How does water rise up to make the clouds?"
So that's a good question, Logan. So the biggest reason is generally going to be, probably the most common, especially as we get into the summertime, is going to be just from the sun coming out and warming everything up. So hot air rises and cold air sinks. So as the sun comes out and shines down for the day, it starts to heat up the ground really easily. You know, during the summer, if you touch the road, the blacktop, it gets really hot. So what happens is the same sort of thing, but over a much bigger area. That sun just basically comes out and charges everything up. It heats everything up, so that air ultimately just kind of starts to rise. So that's why there will be a lot of days that start off perfectly blue, clear skies during the summer, but then we end up with quite a bit of cloud cover, and ultimately we might end up with thunderstorms. This really simple idea right here, sun coming out, heating up the ground, and then floating that air up into the sky, that's where a lot of thunderstorms begin. That's kind of where, I guess you could say, a lot of thunderstorms are born and then kind of turn into a much bigger storm.
And not just the ground, lakes, rivers.
Yeah, exactly.
Puddle.
Heating everything up. Yep.
So at the beginning of the day, there could be a puddle on the ground, but then that puddle might be gone, and it's disappeared into the air.
Yep, it evaporates right there. So, and remember, because we don't have an ocean or anything right here, there's still water in all of this air. That'll be another topic we cover, is humidity and how that makes us feel when it's really humid or when the air's really dry, what that can do. So all sorts of different things at play there.
And just one more about if the jar or bottle is bigger, is it more of a cloud?
So that's going to I don't think so. What it will really do is you'll have a bigger cloud. So let's say if your bottle's bigger, there'll be more water droplets that you're trying to look through. So it might look darker, kind of the same way as with our thunderstorm. Those clouds are so tall. But generally, you're still going to get about the same cloud. Inside the jar, I guess it would be the same thing if you had, let's say, maybe a big a plastic bottle from Costco or something that had maybe cheese puffs or something like that in it. You could use that, and that would probably give you a thicker looking cloud, so it might make it a little bit more impressive. But it's really just about the fact that there is water floating around in here that we just can't see, and what we're trying to do is condense it out. We're trying to turn it from a gas into those little teeny tiny cloud droplets. And again, when I say teeny tiny, they're really small. It's just when they're in a cloud, there are so many of them. That's why we see those big puffy clouds out there in the sky. Thank you guys again for tuning in. I hope you had some fun. Again, we're going to do this each week. And then Logan, the last thing here, sorry, just meant to get back to this. The other big thing that lifts the air is going to be our frontal boundaries, whether it's a warm front or a cold front. So that's often why you see big changes in weather as those fronts do move through. I actually have to run. I'm scheduled to give blood this afternoon, so I'm going to go do that really quickly. So thank you guys.
If you guys
again
do
for tuning in.
post a picture in the comments of your clouds.
That would be awesome. Let me know how they work for you. All right, guys, thanks again for tuning in, and I hope you have a great rest of your afternoon.